Welcome everyone to the PekaSys Bubbler webinar. We are glad to have you here, and I must say that we are joining you from different parts of the country today, which makes it great and very convenient for you and for us. All of the attendees are joining the webinar in muted, but please feel free to click on the chat box and ask any questions, and I will field those questions to our presenters as they come in. You can also raise your hand, and I'll be watching for people to raise their hand with that little hand icon that you see, and we'll be able to unmute you to ask questions. So we'd like to go ahead and get started. I am Marcia Neese, Marketing and Communications Manager for Jensen Precast, and I am moderating the webinar today. We've had a lot of people ask, well, okay, we know Jensen Precast. They make precast concrete septic tanks. What do you know about advanced on-site wastewater treatment? Well, you're right. We know a lot about precast concrete septic tanks. Don Jensen founded the company in 1968 to make septic tanks. So we've been making septic tanks for 47 years. We have grown from the first location in Sparks, Nevada, to now 15 facilities throughout California, Nevada, Arizona, and Hawaii. We have over 1,500 products with over 5,000 variations on those 1,500 products. The company was founded by Don Jensen. He is still our CEO. All of his children actually work for the company. It's a family-owned company, and we've grown to be one of the largest independently family-owned companies in the United States. The presenters today are Charles Ray. He is the ANUA manager at Environmental North America, and Colin Bishop with ANUA. He's the director of Environmental for North America. Also with us, and you'll see him on the webcam right now, is Mike Elliott. Mike, wave. Mike actually came on board with Jensen Precast as a specialist in advanced on-site wastewater treatment several years ago when the decision was made by the family to expand our solutions for on-site treatment. It's been great having him on board. He's extremely knowledgeable. He's a designer himself, and so that's been very, very helpful. Tanya Leffler joined us, gosh, about a year or so ago, and she's Mike's right hand, working mainly in Southern California, but really throughout the state. So wave, Tanya. Wave to the audience. Thank you. So I am going to introduce the presentation now with Colin and Charles. Unfortunately, their webcam is slowing their computer down, so you won't see them on webcam today, and you can turn all of our webcams off anytime you like to as attendees. So, Colin, I am going to turn the control over to you.
All right, we're here. This is Colin Bishop speaking.
And this is Charles Ray.
And we're glad to be with you all today. Just want to point out, you can't see us on the webcam, but I am not wearing the cowboy hat today. So just want to point that out. So glad you could be here. We're going to be talking about the PekaSys Bubbler Sequencing Batch Reactor. It's a technology that was originally developed in Germany and was brought over here to the U.S. by the current owner of PekaSys, and that would be Josh Meyer. And I think he may be on the webinar today. Hopefully he is. And this technology has been deployed over the last few years around the U.S., and we just wanted to introduce it to everyone on the webinar today. No, Marcia, if it's...
You should have control, Colin.
Yeah, it's not. It just came up. Hold on. I'll have it for a second.
Colin and Charles are traveling today, and they're obviously at a hotel where the internet speed isn't as high as it is on our end.
There you go. Hold on. Well, it keeps popping up. Your little mouse does, and it goes away.
Yeah, you are presenter, so.
Yeah, you may just want to grab it back and do next slide. I'll just next slide, Marcia. So.
Okay, I can do that.
Okay, forward. So sequencing batch reactors have been around for quite a while. I mean, they originally were developed decades and decades ago in the municipal sector, and there's some distinct advantages to them. Obviously, we want to provide, any of this treatment that we're doing, we're trying to create a lot of times aerobic conditions or an oxygen-rich environment. We do this in batches, so when you think of a lot of treatment processes, they tend to be step by step by step through different sets of tanks. In a sequencing batch reactor, we're going to do all the steps in one or two chambers of a tank, and then we have control of that process as it goes through those different steps. And so because of that, because we have that great control of the process, and we're not allowing essentially the homeowner and how they use the water in their house to dictate how that's going to travel through the system, that it more effectively mimics like what the processes that would go on in nature out in the environment. Next slide.
Oops.
See if I have it. So you can see there's typically SBRs, and you can look this up on the internet, and you'll find different graphics, but there's typically 5 steps. The first step is where effluent is brought over and filled into the reactor chamber, and then the aeration cycle starts. Now the aeration cycle is going to be variable. That can be adjusted based on the flow that you're seeing and also the waste strength. Some of that process will be self-adjusting through the panel. But it's through that stage in stage 2 that we cycle and do aeration. We can turn the air off and allow for denitrification. So one of the unique things about SBRs is they tend to do simultaneous nitrification and denitrification, which is not typically what you see in most other processes. The next stage would be if you look over on the right side, number 3, that's the sedimentation or the clarification stage. That's where you're going to leave that chamber quiet for a couple hours and allow the solids to settle out into the bottom of that tank. And then that leads you over after that time cycle into the clear water discharge. One of the advantages with this technology on the residential level is it has the built-in discharge pump, saving you space of having to have another pump tank. And then after the settling period, we're going to take some of that clear water, pump it out to the drain field or further down the line for treatment. And then after that happens, then there's a sludge return cycle. So the aerator will come on. You don't see a box there for step 5, but the aerator will come on, stir up the contents of the tank again, and then you'll pump off some of the sludge. So when you look at the anatomy of SBR, on the residential level, we typically are going to have a 2-chamber tank. One of the advantages is you can do all this in one precast concrete tank. As you get into bigger systems, you can break these into 2 separate tanks, or if you're doing a retrofit situation, you could utilize, for example, the existing septic tank and add the reactor chamber. But it's basically broken into a pretreatment chamber or a primary tank, and this can be just like a normal septic tank that's set up 2/3, 1/3. The reactor side, you can see there's 3 things in there. There's the aerator, which is shown in the middle. There's the sludge return pump, which also acts as a siphon during the fill cycle. and then there's the clear water discharge pump. So it's really simple. One of the nice things about this technology is we don't have to ship tanks all over the U.S. We can actually ship all these parts and components in boxes, and so it's real cost effective and helpful to get it all around where you need to get it around to. Go to the next slide. So one of the things it's referred to as is a step fill process, as we talked about just a little earlier. And so through that smart panel, you're able to know when effluent enters into and when you're filling it in. So one of the advantages you can imagine is I'm going to take a discrete volume of water and bring that into the reactor chamber. And that, because I know what the volume that I'm aerating, that's why I get more efficient treatment. So if you compare that to other conventional ATUs or treatment processes that don't control time, you know, somebody could uncork their garden tub, have a dishwasher load going. You go back up one. Have the washing machine going. All those processes could be going on, and as all that slug of water goes out through a treatment system that's a gravity treatment system, you have no control over the process. So you might be under aerating at times, you might be over aerating at times, and then the other problem you can see down there where it talks about the avoidance of sludge bulking. You're not going to wash solids out to your drain field because of those high flows that go through there. So the huge advantage to this, or one of them, is that we really have optimization of the treatment process in that reactor chamber, and that leads to healthy flock formation, healthy bacterial colonies that are actually going to perform the treatment the way we want it to. Now you go to the next slide. So obviously on the pre-treatment side, just like a lot of people, we use a septic tank and we circulate through that as their anoxic zone and carbon source. It's the same thing in this. When we bring effluent over from the pre-treatment tank over to the reactor chamber, that provides a carbon source for the nitrified effluent that's already there. And so one of the advantages to this technology is you get really high levels of nitrogen reduction, which for a lot of places out in the West Coast, you know, West California, Arizona, some of the different intermountain states, you know, nitrogen is one of the big limiting factors. Next slide. Okay, so you can see your typical two-compartment concrete septic tank. So one of the differences you can tell is there's no flow through the baffle. So you wouldn't have holes in the baffle, or you wouldn't have T's up and over. It would actually be a solid baffle with just airspace at the top. And on the primary side, if you look over to the left there, you can see that there's different working volumes. So what controls the height of water in the first chamber is that sludge return pump in the second chamber. So when we want to bring water over from the first chamber to the reactor tank, that pump will come on and pulse for a few seconds. That will start a siphon process, and water will siphon from the first chamber over to the second chamber. And then that little pipe that you see that's on the left side of the baffle wall, I'll show you a picture here in a minute where there's a siphon hole in that. And as the water comes down in that primary side, it'll hit that siphon hole, and that will actually break the siphon. And so you can also see, of course, at the top of that primary side or pre-treatment tank that we also have buffering capacity beyond the working volume. And then if you look over at the left side, oops, I just touched something on my screen here. Hold on. There we go. You can see the working volume and the base volume that's there. There would also be, of course, overflow capacity on the reactor chamber that's there on the second side. So from a design standpoint, you can use any vessel, which you'll see here in a little bit, and the height of the siphon hole there is something that is based on the different tanks, as well as the height of the float switch and the height of the pumps as well. Okay, go to the next slide. So this just shows you, I mean, it's real simple. It's just a hole, like a 3/8 inch hole that's drilled in the pipe. When the water level comes down on that primary side, and it hits that hole, that's going to suck the air in, and that will break the water flow over into the reactor chamber. All right, next slide. So one of the things that you can look at doing from a design standpoint is if you need, we encounter a lot of different situations in on-site systems. You may have, for instance, a home that is not used a lot during the week, and maybe they run a bed and breakfast type business out of it where they do a lot of stuff over the weekend. Maybe they have parties on the weekend. As you know, there's a number of different scenarios in the industry that we deal with, and so if you need to add a larger pre-treatment tank, that will obviously add more buffer volume for you, and that's one thing from a flexible design standpoint that you can do is you can increase. It's real inexpensive, obviously, to increase tank size and provide more volume if necessary on the primary side. All right, next slide. So this chart is in our reference manual. So for that pre-treatment volume, there's only two design things you need to remember for these bubblers from tank sizing. There's a pre-treatment tank sizing, and there's the reactor tank sizing. The pre-treatment tank sizing is just going to be sized based on how you would size a septic tank in your area. So if your local code or your state code, a 3-bedroom home, says you need to have a 1,000-gallon septic tank, then that would be the size of your pre-treatment tank. And then this table shows you the size of the reactor tank that you have to have, and you can see that there's a range there. So, and this is based on the NSF testing that was done, what that range is. So one of the things with the SBR, though, like all systems, is you want to try to optimize the flow design of this thing. And that's where sometimes the on-site codes, it gets a little bit squirrely because a 4-bedroom home may be designed on 600 gallons a day, but in actuality, they may only be using like 200 to 300 gallons a day. So it's something to keep in mind when you look at sizing these, because we really want to size that reactor chamber based on the actual flow that it's seeing. So that's one thing to consider. And again, you can find this in the reference manual, which is on our website. Next slide. So as we talked about, really the bubbler is going to allow you ultimate flexibility in tank selection. So there's a few keys that you need to be aware of. We want the tanks absolutely have to be watertight and structurally sound. And then, as I mentioned earlier with that dividing wall, that needs to be, there's a couple things with that dividing wall. It needs to be watertight because we can't have effluent from the pre-treatment tank kind of squeaking around the wall there and getting over to the reactor chamber, because then we're not going to be putting out effluent that's treated to the level that we want it to be. The other thing is it needs to be able to withstand the pressure differences. The liquid levels in those two chambers are going to be different levels. And so it has to be able to structurally handle that, that non-shared liquid level. So that's something to consider. So for a precaster like Jensen Precast, it's not an issue. They can, if you tell them, I need this baffle, I need it to be watertight, it needs to be structurally sound. For precasters, that's not hard for them to do. But if you run into a situation where you're dealing with a fiberglass tank or you're dealing with a plastic tank, there are some manufacturers that those baffles are watertight and they're structurally sound, and it could handle this type of situation. And there's other manufacturers that is not true. The baffle, either the baffle's not watertight or it's not structurally sound enough to be able to handle different liquid levels. So keep that in mind when you're doing designs on these. Next slide. This just shows you, for example, different precast ways. So the top left corner is a 2-compartment precast tank. The tanks that are typically 2/3, 1/3 split are optimal for these systems. The 2/3 side being your pretreatment side and the 1/3 side being the reactor chamber. You could do a 3-compartment tank if you had to. Now where you might see this is, even though this has a built-in discharge pump, you may have a requirement if you have a very large field that needs to be dosed, or a situation where the pump that is in the reactor chamber is not big enough, then you could have a 3rd compartment there to pump out of. You can use the round cylindrical tanks. The bottom right-hand corner shows a single compartment pre-treatment tank followed by like a precast concrete manhole. So one of the great advantages of this is whatever you can get your hands on for tanks, they're good quality and watertight, and you can use them for this type of system. All right, next slide. Obviously, the advertisement you guys received for this webinar talked about the brain. With an SBR, it's all about the controls. So you have to be able to control those different processes that are going on, those different steps, and so they're absolutely critical for any SBR. The good news is we work with a company that produces the controls, that they're in the on-site business. It's Alderon Industries, and they, with the software that was developed and programmed into the Alderon panels, it actually is a successful implementation of the on-site market. So you can also see why in the on-site market we need to have buffering capacity in the tanks, because if we're aerating a discrete volume, you can't have effluent flowing into the treatment chamber at that time. So that's why another reason you have to have that buffering capacity. But we have very robust controls that come along with this. They can be reprogrammed. If the situation changes or the design parameters change, it's very easy to reprogram this and swap that out if you need to. It's also easier for the operator to make minor adjustments on timer cycles or settings if they need to. So if you get out there and maybe the water use and the wave strength is not as high as you thought it was going to be when it started up, it's easy to throttle back the aeration cycle and not aerate as much and change some of those parameters. So this is critical and for any SBR, and one of the good things is this has been robustly developed and tested and is applicable to the market that we all work in. So it's the brain. So always remember, the SBRs, it doesn't matter whether it's ours or anybody else's. You better know what the brain is, and you really need to make sure that you have robust controls of that. The other thing to point out in the picture on the left, some states require auto dialers, and so the picture that you see on the panel there actually shows the auto dialer built into it, but there's still a lot of jurisdictions that don't have that, and so that if in your area, if you don't have that type of thing going on, then you wouldn't see that auto dialer in there that's on the bottom left picture. All right, moving on.
We have a poll question here, so let me launch the poll for the attendees, and so you'll be able to answer the question. And we'll give you just a few more seconds to answer. Okay, it looks like everybody's answered the question. Hold on. I'm not sure what just happened. We have 38% of the audience saying yes, and 62% saying no. So
Okay.
we'll move on to the next slide. Hopefully that helps. Are you ready, Colin?
Yep, I'm not seeing the slide yet. It's still showing the poll here.
Sorry.
I don't know if our machine's so slow that it's...
I'm not sure. What just happened? Sorry, people. I'm not sure what's happening here. Okay. Okay, are we back now?
Yeah.
Okay, Sorry about that. We're using a new service, and I wasn't able to find the right button to close that hole.
Not a problem. Okay, so as we talked about, systems like the PekaSys Bubbler are going to provide a high oxygen environment. So when the effluent, when it's treated, will have a high level of dissolved oxygen in it. A lot of conventional drain fields, as you know, will build up biomat, and in some cases they build up a significant enough biomat that you actually tilt it towards the anaerobic microorganisms. And this is actually very common because part of the problem anymore is that we still size drain fields based on hydraulic loading, but in reality most of the problems are occurring from an organic loading standpoint. So when you talk about biochemical oxygen demand, or the 5-day BOD that you've probably all seen that, you know, we're measuring, especially if we're doing a CBOD test, for example, we'll be measuring the carbon in the wastewater, and obviously the more carbon and nitrogen and things like that is, the more food there is. If you go back to the other slide, Marcia, there is for the biomat. So is that what happens in the trenches or the beds is that gets thicker and thicker, it basically seals off and restricts the soil acceptance of the water into the soil, and that's where you get the hydraulic overloading and surfacing with that. So now you go to the next one, Marcia. So when I put oxygen out there, so once I have an effluent that's now treated, which would be low in carbon, high in oxygen, that biomat is going to start to break down, and eventually what will happen is you can restore the soil acceptance. But this should be pointed out that you can't fix every drain field this way. So if there's root intrusion, or there's like a high water table or something else going on as the cause of a drain field failure, this is not going to remedy that. This would only remedy situations that are biological failures. So if you can confirm that it's a biological failure, then a process like this would be able to rejuvenate the drain field. Next slide. The bubbler has been tested to standards 40 and 245. So standard 40 is the one that most people are probably familiar with. That basically just looks at BOD and TSS. And standard 245 is actually the nitrogen reduction standard, and that demonstrates that you can get less than 20 milligrams per liter or 50% reduction in total nitrogen. So for the NSF certifications, there's two kits. There's one that does up to 800 gallons per day, and then there's another one that does up to 1,500 gallons per day. The basic difference in those is just the size of the aerator. So the sludge return pump and the discharge pump would be the same, but the aerator is a larger aerator for the higher flows. And then what we don't have here, because NSF only applies to residential systems, is when you get into commercial systems, we can go up to a lot higher flows than 1,500 gallons per day. But those would all be designed based on the actual establishments that you'd be looking at, or the commercial facilities. You can see with the NSF test results, real good on BOD and TSS, good nitrification, got the ammonia down low, and the total nitrogen, you know, less than 20. So high level, it's almost a 60% nitrogen reduction during the NSF testing. So if you have areas out west, again, like I said, where nitrogen reduction is a restriction, then you can use this as the first level denitrification. What we're finding around the country is the standards are tightening up greatly on both ammonia and total nitrogen. So states are becoming less and less concerned with it's not that BOD and TSS is something they ignore, but we're kind of moving beyond BOD, and they're looking heavily at ammonia and total nitrogen. In some areas, the total nitrogen, we're seeing stuff down under 10 is what the requirement is. In some areas, we're seeing ammonia down under 1 as a requirement. So what we do with the bubbler, because it has that clear water discharge pump built into it, it makes it really easy to put another treatment technology behind it. And we're going to show you that here just a little bit later, where we're able to package more treatment behind it, provide it less expensively, and kind of get a 2-for-1 or 3-for-1, where you get really high-level treatment, and you can actually meet the standards that the different states or jurisdictions are setting. Next slide.
We have another poll question here. This is a multiple choice, and you may click on as many as are applicable in your area.
I believe the FOB should be FOG, right? Fats, oils, and grease.
Oh, yes,
Is that right?
there's a typo, FOG, yes. People are still voting. Okay, I'm going to close this poll now and share it with the audience.
Right, so you're seeing from the poll, nitrogen obviously is a big issue. Okay. Interesting, the fats, oils, and grease is pretty high up there too. And that's one of the things we often face, just kind of off topic a little bit, but when you get into the commercial food establishments and places that generate grease, you're getting into a whole different game. And so that's something that we take a whole different design approach than what we would from residential. But so just know that there's tools out there, and we can help anybody with that if that's of interest to you. So in summarizing the benefits with the PekaSys Bubbler, the other thing I'd point out to you, if any of you have any questions, you can jump in and turn your microphone on and ask a question, or I think you can probably send it to Marcia too, in the little box down there. So a couple summary benefits, just reminders, you can use any type of tank. You can see that it's very simple technology. You have an aerator, you have a couple pumps, it's controlled by a smart panel. So there's not things to clog up, there's not filters that need to be cleaned. It's a very simple operation, which in a residential setting is really nice, as we all know. Jumping ahead, that's okay. Just to remind you, residential commercial configurations are available. We've talked more about residential today, but you can do larger commercial systems if that's of interest to people. And I guess we now have another poll question.
Yes, we do. And again, it is a multiple choice, and you can answer as you can click on as many things that that are applicable to you. Looks like a lot of people are dealing with soils and groundwater so far.
Perfect.
Answers are still coming in. Looks like most everybody is dealing with groundwaters. I'm going to go ahead and close this poll and share the answers with everyone.
Oh, wow. Yeah. I guess if some of you don't mind, can you enlighten what you're specifically seeing with respect to groundwater, besides it's depleting out there? Anybody, any of the participants out there want to type a message or jump in?
We do have a hand raised.
Okay.
His hand went down. He doesn't seem to be hooked up to audio. So if you could please chat in your question, I will relay that to Colin.
Yeah, I can see there's a little chat box down there, which Charlie and I can see that.
Okay,
so
great.
If you guys want to type in anything, that would be great. We'll keep moving on. So go ahead and type in any groundwater issues that you're seeing.
Lance has
so in other parts of the country, a lot of what we see are very high groundwater, either two things, high groundwater tables, or people wanting to do source water protection of the groundwater, or they might have both of those situations.
It looks like Lance has a question, Colin. I'm going to, Lance, you're unmuted if you'd like to ask your question. They're chatting in their questions. Can you see those, Colin?
No. I see the chat box, but that hasn't.
Lance says groundwater separation is.
Oh, I see. I can scroll up. Yeah.
And Todd says on a new construction situation, approval of separation to high water mark.
Right. Okay. So I think with the new regulations, you may be facing some of the challenges that other people are facing in other parts of the country. So we work in a lot of situations at very high groundwater tables. With those reduced separations, obviously people want higher treatment. That typically gets done in two different ways. It's either going to be nitrogen or it's going to be pathogens, like either looking at E. coli or both. So with these technologies, so if you have a groundwater situation where you want to do pathogen reduction, the bubbler is going to give you the nitrogen reduction. You can couple that, which we'll show you here in a little bit, with another technology, and you can get the nitrogen and pathogen reduction, which would allow you to reduce vertical separation. So I can see the case study coming up. So we'll dig into what we did here.
Yeah, Chris also has a comment. He's saying septic discharges to ground where drinking water is drawn. Therefore, groundwater is important with respect to nitrogen.
Right. So that I think we're all on the same page. I mean, our goal is not unlike all of your goals. Is that we want to protect source water, and that's really I think sometimes in our industry we forget that. People think we're in the septic business. We're not in the septic business. We're actually in the business of protecting source water and also recreational water, basically all sources of water, to make sure that it's available and usable in the ways that it needs to be done. So, Mike, if you want to unmute, since you were involved in this project in California, I'll let you take over here, and you can tell people about this project you're involved in. And there's a couple pictures after this, Mike, just to let you know. So unmute his microphone.
Okay.
Yeah, I've unmuted Mike, so.
Hello. Yeah, this was kind of a weird situation because we actually don't have a water table there in the wintertime when you think you would, but there's actually a water table, excuse me, there's actually a water table during the summer because they flood irrigate, and they flood irrigate so massively that it actually brings the water table on the entire valley up to within a couple feet of the surface. And so they weren't going to get to build on this lot, and so we used the PekaSys with the pure flow discharge on a pad in order first to control the vertical separation, and we were able to get a reduction, addressing those comments that came in about the, the separation with the new construction. We were able to argue a less restrictive separation, so in this case 2 feet rather than 5 feet, by using one treatment model before the other, so essentially getting tertiary treatment, for lack of a better way to say it. And so having the pure flow pad allowed us to set the vertical separation pretty well. It's a pretty flat area, so that was easy enough anyway. And then it also gave kind of a redundancy to the treatment. If there ever was a hiccup or anything, we have another way to catch that before it gets into the groundwater. So that made the regulatory bodies feel better about it. We were able to install it very quickly. It was very easy to design. Myself and one other person had it put in, in about 3/4 of a day. The holes were already dug, but so it was really easy. The county really likes it. Here's the picture of the drain field. You can see the pure flow modules there. The house hadn't been landscaped yet, so at this time you'd see grass on that mound there, and that's about 18 inches above grade at that point. And then the PekaSys, you could see that's actually my work car there in the background with the trunk open. That's really where I do most of my work, is out of a trunk of a car. But you can see the septic tank riser there. That's where the PekaSys is located, down in that one tank. And so we were able to, if you talk about a cost standpoint, it was also good for this job because we were able to put this, make a buildable, or excuse me, a lot buildable. We're also able to beat all the competitors on price, which was important as it is for most of the installers in the world. The reason we were able to do that is, first the price of the units is fairly low comparatively to other equivalent treatment technologies, but also we were able to reduce it down to one tank, so we saved the price of a dose tank. And we were also able to, instead of using 3 PuraFlow modules, use only 2 because of the pretreatment, which saved some money there. So again, we were able to put this tertiary treatment system in, get a lot to be buildable, and I mean, essentially I had this on site for, you know, way less than what the competitors were doing, and no trip fields or anything like that, which would have been the alternative. So it's also a very simple system to maintain. We don't have a lot of bells and whistles. You know, there's essentially just the pump units you're seeing there. Everything else is passive. And so, you know, we're not flushing filters or any of that kind of stuff, which made it very easy to deal with all the way around.
Thanks, Mike. So just so for those of you that aren't familiar with the PuraFlow system, that's another technology we make. It's a key biofilter, and one of the huge advantages of key biofilter is very high quality effluent, but it's also very well known for its pathogen reduction. So we get, and it can also do enhanced nitrogen reduction too. So we get great nitrogen reduction with the bubbler, and then we put the key biofilter behind it, and that knocks out the pathogens and more nitrogen. And then when you go into shallow dispersal, like the pad dispersal, you get even more denitrification there. So you're typically well under 10 total nitrogen, and your pathogens are going to be down at, you know, full body contact standards, you know, right when you hit the soil or within a few inches of the soil. So from a water protection standpoint, it's pretty much about the highest quality water you can get, right up there with those other types of treatment technologies that can do that. But you can see one of the things we're starting to do is bundle the technologies in the treatment processes to get the different results depending on what the site conditions are. So here's a project in New Jersey. This hasn't gone in yet, and I'll let Charlie talk a little bit about this one since he's involved in it.
Yeah, this is a repair situation, and it's an incredibly difficult site. So it's a 4-bedroom application. It was actually a failed conventional system, and the property was completely surrounded by wetlands, and it was also in a flood hazard area. So we worked with an engineer out of New Jersey, and frankly, it's really taken off out in New Jersey because of the really small areas, high population density, and you know, I'm anticipating probably 80% of the installs will be failed soil absorption systems out there. And this went into an LPP, or a low pressure drain field. So go to the next one. So it's just a site plan that we have here. I'm anticipating that probably close to 80% of PekaSys' use will be in the retrofit market where you've got failed systems. So I know this is a small image there, but you can actually see the boundaries for the wetland. I mean, it literally, so, you know, the solution, you know, what is the solution for a failed system? They're not going to kick the people out of their home. And this was a very cost-effective solution, actually. What I'm finding from our distribution in New Jersey is the treatment level of the PekaSys combined with PuraFlow, and if you look to your left, if you have a microscope, you can actually see they've got modules built in. So, oh, no, that's right. This is a PP. I see that so much. But this is a very cost-effective solution and very high treatment, you know, to where they're literally, New Jersey's very strict in their regulatory code, probably one of the most strict in the country, frankly, and they were able to put that in that sensitive area. So that's just a cutaway. This was this designer that I worked with actually wanted to take some extra steps, which I always applaud, and he actually had a bit larger primary tank than actually was necessary, but that's okay. I mean, the cost difference between a 1,000-gallon and 2,000-gallon tank is pretty minimal. And in the event that they ever upgraded the home, he'd have that capacity. That's what I always tell people, is that the most expensive thing to replace going forward, if you decide you're going to upgrade or add to your home, is the septic tanks. So you can just see his design. Yeah.
Charles, Chris has a couple of questions. He wants to know what the approximate yearly maintenance or what's the typical, and it's The rest of his question was gone there, but he also wants to know what the pump lifespan is. And I'm not sure, Chris, if that was applying to the California PureFlow case study or the New Jersey one.
Well, you know, well, one thing for New Jersey, we actually, it's a state rule. It's in the code that we have a 5-year, minimum 5-year warranty on all treatment products, which is 3 years over and above any other place in the country that I'm aware of. So, that is an idea. It's hard to say.
Yeah, the maintenance is twice a year, which is what's required by NSF. So it's pretty minimal visit. Like you would be looking at your primary side and looking at normal accumulations there. On the treatment side, you can actually do a settleability test and see how the sludge is settling out and then determine whether you need to pump that side out or not. So when you look at it, there's really not a lot of components. You're going to check the aerator, check your pumps. The pumps that are in there are actually Gould's pumps, and I would expect a lifespan on those of quite a number of years. I mean, that's not something that you're going to see less than 5 years going out. I would be thinking you'd be more up in the 10-plus year range on pump. Most pumps today are last a long time.
And
so.
keep in mind, these are not running 24/7.
Right.
And also good for intermittent use because they're going to cycle based on flow coming in. So that's part of the smart control. So if you have less flows than anticipated through the week, I mean, it's not going to run as often. So it's it's good for intermittent flows as well. In our manual, it talks a little bit about the maintenance. I think it's relatively simple. My service providers out in New Jersey are pretty pleased with it so far in regards to what they're having to deal with. And there's only there's 3 mechanical items in the system itself. And the real key, which is kind of unique, is how they pull the sludge. And they go down with like a sludge judge, and they're just checking the sludge level to see how healthy it is. And it's a visual type of application, and you can make adjustments based on what the actual sludge looks like. So there's not a whole lot to a maintenance visit per se.
I'm going to jump in here for a quick second. We have 8 minutes left in our 60-minute session, so we're going to go ahead and go through the slides, but we will hang around after the 60 minutes for anybody who has any questions, and I can unmute anyone who has questions so you can ask the guys directly. So do we want to go into the Massachusetts study now?
Yeah, I just want to, because it brought up one point, and then we'll move into that, is so the aerator, for example, most every other ATU that I'm aware of, the aerator's running 24 hours a day, whether it needs to or not. So this technology, that's one of the big differences. That aerator is only going to be on for at a maximum probably an hour to 2 every day based on the cycle it's going through. So that provides you a couple things. Number one, the aerator is going to last a long time. And number 2, your energy usage is significantly lower with this type of system than it is with the other technologies where the aerators are running 24 hours a day. So it's a good question. I'm glad you brought it up on the maintenance because it brought out a few other points. So this is a design in Massachusetts. It's in Plymouth. Massachusetts has a very high total nitrogen standard in place in eastern Massachusetts there. And so most everything, like Charlie talked about in New Jersey, Massachusetts would be the same. It's not necessarily a lot of new construction that's going on. It's a lot of retrofits and replacements of failed systems. And in some of these states, it's actually literally old cesspools that are taken out of commission. This particular case, they had an existing conventional system with a tank. This one where the tank is going to be utilized for the pretreatment tank. The thing you'll see is it's extremely space limited. The other requirement that Massachusetts has is that you have to do a polishing bottomless sand filter behind the treatment technology to do further renovation treatment of the effluent. And in this case, we were able to get the PureFlow swapped out in lieu of a bottomless sand filter. And then because of the shallow rock that this had, it ended up being a mounded pad dispersal. So you can go to the next one, Marcia. So if you look at the site plan here, you'll see this is how small this site is. It's really, really small. This one's actually going to be going in the month of May, so it's about to be under construction. So you can see the driveway there on the left at the bottom of the house. Right beyond the deck is the existing tank they're going to use as a pretreatment tank. So all they had to add to this site was another tank for the reactor tank, 2 PuraFlow modules, and then the mounded pad that's below it. So a mounded pad is built a lot like a Wisconsin mound, only you end up with a lot less sand in it, and you end up with a lot less of a footprint because it's pre-treated effluent. So you can see that that mound is actually pretty small. So that's it. This is for this very tight site that needed high-level treatment. This is where, again, we're able to use existing components, add new treatment to get nitrogen reduction, and then add further polishing and elevated drain field to actually meet the site constraints. It's so space limited. All right, next one.
So we have another poll. This is our last one, and only one answer here for each attendee. Thanks, everybody, for participating in these polls. It's very helpful. Okay, it looks like nearly everyone has voted, so I'm going to close this poll and share the results.
Sometimes it's just
Yeah, so you look at the always and sometimes. That's probably well over half. So.
Okay, I'm going to hide this now, and we will move on.
almost there.
All right, so we have a nitrogen calc tool. I'm glad we have this in here because so many of you said nitrogen was an issue. So we have a lot of design spreadsheets, packages, and in a lot of states we work in, both the designers use these and also the regulators use it to check their work. So these are available. We'll provide them to anybody. We actually encourage people to use them, even if they're helpful in selecting something that may not be our technology. This is always trying to raise the level of awareness in the industry and to help move things forward. So if you could pull that spreadsheet up, Marcia, we can talk about that.
Absolutely. Absolutely.
Yeah, we won't have time to go through it, but if you could just pull it up so they could see it.
There you go.
We can email it if you request it.
I don't know, has it come up on anybody else's screen? Because I'm still seeing the
I'm
PowerPoint.
seeing it on my screen.
All right, mine may not be refreshing. So what we did is we take the nitrogen loading. There's inputs with that spreadsheet that you can actually look at the number of people, the flow per day, the nitrogen input in pounds per day, and also the treatment standard that you're trying to achieve. So if you look down at the bottom, you can see different nitrogen treatment standards, and you can even input your own. So that everything, one of the things about the spreadsheets we do is the only stuff you can change is the green shaded boxes. So everything else will auto-calc for you, and you don't have to worry about messing stuff up. So these are helpful for whether it's a residential or probably more so for commercial systems where you can actually do a nitrogen analysis. And then you can see all the different technologies that we have in the middle part, whether it's the PekaSys Bubbler by itself, PuraFlow, Platinum, which is another system that we have, or combinations of those systems. And also at the bottom of that, the combination of that with pad dispersal, then you can see how the expected nitrogen reduction that you would get from those technologies. Now, you probably ask where these numbers come from. These numbers actually come from third-party testing. Most of it probably comes from third-party field testing, stuff that's actually out in the field where we know what the reductions are and what the performance is. So between the pad, for example, and then PuraFlow, and whether it's single pass or recirc, and then the other technologies, we have a good handle on the type of reductions that we expect to see out of that. So obviously these numbers, the reductions aren't fixed in stone. There's parameters that play into that where the numbers could be moving around just a little bit, but it'll at least give you a target that you know you're in the neighborhood of where you want to be for nitrogen reduction, which for you guys that participated in the poll, you said that's a big issue for you. And I believe that's all we have. So I don't know if anyone has any questions or comments, but
well, it looks like our time is just about up, but we will hang around for anyone who wants to stay on board and answer your questions. I'm going to stop the recording of the webinar now, but we will hang around for a few minutes for questions.